Hey guys, welcome back to Taylor Series video 6. So far we were able to write a Taylor series for e to the x, sine x, cosine x, natural log of x, and 1 over x in the past 5 videos. So this was really easy to do because all we had to do was take derivatives, and the derivatives of those guys were so simple. But in many cases, the functions that we're going to be given are going to be so challenging to take the derivatives of. So we have to come up with a different way to write the Taylor series or a polynomial function to approximate the function that we're given. Okay, so this is how we're going to do it. We're going to start off with this. I'm sure a lot of people seen this already, but 1 plus r squared plus r to the third and so on is equal to this guy 1 over 1 minus r. You can look this up in a pre-calculus book and there's a lot of proofs on it, and that's great. Okay, so you guys will recognize this as a geometric series. So a geometric series is basically saying that the common ratio to get from here to here, I just multiply by the same exact common ratio r, okay? So r, 1 times r is r times r is r squared, and so on. So this is our common ratio. What I want to do is I want to get my function that I'm given, that I need to write Taylor series, to write a Taylor series in, to look like this. But the most important part is to get this 1 here, okay? We don't care if this is a 1, 7, or 2x or anything else. We just need this to be a 1. This guy here is going to be our ratio. So once I get this function, I need to do something to make it look like this. All right, so let's do that. So in this example, how to write the Taylor series for 1 over x centered about x equals 1, most of you might say, oh, we saw this in the last video, it's very simple. I'm going to do this problem to show you how it matches and with the answer that we got from the last video, and then I will start doing some more challenging problems, okay? So we're going to start off with, I need this to be 1 over 1 minus r. You must start that way, okay? And then you have to say that, all right, I need to maneuver this because right now I only have 1 over x. I'm going to put the one that I need there, which is this guy here, and then I'm going to have to sort of compensate because I just changed what the function was. So if I put a 1 there, then I'm going to take away a 1, okay? So let's give a plus sign to the x. And now if you notice, 1 minus 1 is really 0, so I never changed the problem, and I got the 1 that I wanted there. You're going to have to maneuver these functions. So 1 over 1 minus, because I need it to be 1 minus, okay? 1 over 1 minus, and then what am I going to do here? Well, if I do a negative x plus 1, wouldn't that be identical? Sure. Let's take a quick look so you guys could believe me. That's a positive x, and that's a negative 1. So I really didn't change my function at all, okay? So now what you do is you identify this guy as your r based on this formula right here. And this is my r, okay? So now that's my r. What you do is you go back and you say, oh, 1 over 1 minus r is equal to that thing that we wrote on the previous page. Now we can stop here. So it's going to be this guy here, okay? So we write that down. That's our next step. And all we have to do is substitute the r. So 1 plus, and now what was r? Negative x plus 1. Great. What was r? Negative x plus 1 squared, and so on. And then you're basically done creating a Taylor series with 4 terms, okay? And that's it. So some of you might say, well, don't we have to divide by a factorial? Absolutely not, okay? Not in this case. If you were taking multiple derivatives, then absolutely. But when you're doing it using the geometric series or the power series, then you do not do it this way. Now, some of you might say, hey, can we just confirm that? Sure. So this is 1 plus negative x plus 1. This is from our last video, okay? So some of you might say, it doesn't look the same. But guys, if you distribute this and make this a plus, you would get 1 plus negative x plus 1, which is 1 plus negative x plus 1. They do work. I'll do this last one. X minus 1 squared is just x squared minus 2x plus 1. Well, this guy here will give you the same exact thing, right? They're identical, okay? So that's what we're gonna do in our next videos. We're gonna start taking some complex or complicated, which they're really not complicated, some functions, and I'm going to show you how to maneuver them to get into the form of some number. I should have really ran a1 over 1 minus r. I know a lot of you've seen that. The most important thing is this 1 here, okay? So don't forget to subscribe and don't forget to watch all the videos. They'll come together really nicely in the very end. I hope everyone is well.